What is the human microbiome? Though we don't often think about it, we're actually more non-human than human. Trillions of microscopic organisms, or microbes, call the human body home. Organisms such as bacteria, viruses, fungi, and even microscopic animals live all over our body, on our skin, and even inside us. These tiny organisms make up our microbiota, and most of them, about 95%, live in our gastrointestinal tract, more commonly known as our gut. And the combination of microbes, their genes, the environment they live in, and the stuff they produce is called the human microbiome. We've actually known for a long time that the human body is teeming with microscopic organisms. Dutch scientist Antony van Leeuwenhoek observed bacteria scrapings from his mouth way back in 1683. But it's only relatively recently that we've begun to study the relationship between our microbiome and our health. And while the research is still in its infancy, the microbiome has been linked to everything from obesity, asthma and allergies, to autoimmune disorders such as rheumatoid arthritis and diabetes. The microbiome also influences how our brain functions and is linked to conditions such as depression, anxiety and stress. These links explain why there is now an emphasis on creating or maintaining a healthy gut. And a healthy human gut consists of several thousand types of bacteria, as well as other microbes, though some types would be more common than others. The exact composition of a person's microbiota is unique, and it's constantly changing. It depends on what you eat, where you live, who you live with, what you touch, and even how you were born. Before we are born, we have very little, if any, microbes inside us. Microbes really start to colonise our bodies the moment we are born. The way we are born, either naturally or by caesarean, influences the type of microbes we first contact, and hence the type of microbes that will first colonise our bodies. Babies born naturally come into contact with microbes found in the mother's intestinal and vaginal fluids, whereas in a caesarean birth, babies tend to be colonised by microbes typically found on the skin and in hospitals. Similarly, breastfed babies will have a different microbiota profile than formula-fed babies. From the day we are born, our microbiome evolves quickly and reaches maturity during the first 2 to 5 years. After that, it stabilises, resembling that of an adult. As adults, changes to our microbiota are likely to be small, but major shifts in composition can occur when we radically change our diet or take antibiotics, which kill bacteria. Significant life stages such as puberty, pregnancy, and menopause also cause large changes to our microbiome. And as we get older, our microbiome ages too, and the number of microbe species decreases. Since most microbes are in our colon, or large intestine, what we eat feeds our microbiota. And what a healthy microbiota needs are fibre-rich, complex carbohydrates. Simple sugars, found in refined carbohydrates, tend to be absorbed quickly and don't reach the colon for the microorganisms to feast on. But complex carbohydrates can't be digested in the small intestine and make their way into the colon, where bacteria breaks them down through fermentation, enabling us to use nutrients we couldn't otherwise. And the microbiota provides essential vitamins that we can't make ourselves, such as B vitamins. Perhaps most important of all, the microbiota helps our immune system develop, effectively training it to distinguish between good microbes and bad pathogens that cause disease. This symbiotic relationship between humans and the trillions of microscopic organisms that live on and within us has evolved over thousands of years, and we couldn't survive without the many specialised functions they provide.